Hi, I'm Rich with InsideHPC. We're here at ISC 2016 in Frankfurt, Germany, and I'm here with Ken Claffey from Seagate. I think what we should start at the beginning. What's happened since we last talked?
Yeah,
Yeah?
it's been 12 months is pretty crazy, right?
Yeah.
One of the things that we've really been very proud of in terms of our progress, particularly in EMEA over the last 12 months, is we've deployed a number of really significant systems. If you remember when we were back together actually at supercomputing, there was a new supercomputing list back in November. We were together in Austin. And of that, one of the big pieces of news that we were very proud of was of the top 10 supercomputers, 4 of them are actually powered by Seagate. Even more impressive is that 100% of the newest systems are powered by Seagate. When you peel that layer back just a little bit further, actually 3 of those 4 systems are actually from Europe here.
Okay.
So if you look, we have, and the Middle East. So we have KAUST in the Middle East,
Yes.
we've got HLRS, and the Swiss Supercomputing Center.
Yeah.
On top of that, we've also done major deployments at CEA, who was an earlier adopter of our L300 highest performing Lustre platform, which also used our HPC drive, which we also announced at Supercomputing.
So Ken, certainly with Lustre being a strong presence in the top 500, but having Seagate there in that top 10, the best of the best, being the vendor of choice, sounds like, for these ultra-scale machines.
Yeah, if you look at it, I think no other vendor has more, from a storage perspective, has more than a single system, and Seagate has 4. One thing that I just noticed on the updated top 500 list this morning was Stampede, which was previously number 10, just dropped off the top 10. One thing that you may not have picked up in the news just about 10 days ago or so, TAC actually announced Stampede 2. Which I'm sure will put TAC back into the top 10 when it comes in next year.
Yeah.
And actually, Seagate was also selected for that.
Perfect. Okay, so maybe we can switch gears here a little bit and just talk about challenges in general. What are your customers telling you their big challenges out there for storage?
Yeah, if I started from a macro level perspective, it's not the challenges that we see from HPC users really mirror what we're seeing in the broader enterprise. So taking it from a macro Seagate view for a second, really what we're seeing is this data deluge. Whether across all segments of the IT market, storage market, fundamentally you've got more and more data being generated, and nowhere more so is that more evident than in HPC, of course. We've got supercomputers generating massive amounts of data, and it's really signaling the movement away from a compute-centric model to a data-centric model, which I'm sure that's something that you recognize. But when you've got that growing amount of data, it's all against the backdrop of, hey, hang on a second, my budget is actually pretty challenged. So you've got storage becoming a bigger and bigger percentage of the budget against the backdrop of, okay, my budget's getting pretty compressed. So how do you find that balance with, hey, because of the data deluge, I need massive amounts of capacity, but I also need a lot of performance. And there's a lot of confusion amongst the end users as to what's the best architecture. I don't think us as vendors, frankly, are helping that situation right now. I think we're actually creating a lot more of that confusion. On one hand, they're being told Flash solves every problem, but Flash's key attribute is it's really good for certain aspects of performance. Of course, if your applications can take advantage of that, which is not necessarily so easy, but that still doesn't solve my capacity problem. Ultimately, for customers to solve this data deluge problem, more performance, more capacity, with reliability and endurance and security, all the other things that matters to HPC customers, you're going to need the right combination of the right technology, the right tool for the job, and that's really some combination of Flash, some combination of HDDs. And from a Seagate cluster store perspective, from day one, we were shipping with a hybrid architecture. So every building block of our architecture that we shipped always had a combination of Flash and HDD. So while that may be appearing to be from other vendors to be new news and new architecture, that's part of the reason why we've been so successful in the top 10 and indeed the top 500.
All right, well, so Ken, I'm hearing a lot about all-flash arrays. We're all about supercomputing, the very fastest. Why not just throw, all flash at the thing, as much money as possible? Why not just go that route?
I think you said the key words there, as much money as possible. So what users are really struggling with reconciling is, on one hand, I'll build a system full of flash, but my budget is challenged, my budget is constrained, and also, by the way, I need lots of capacity. So if you had unlimited budget, you'd probably go build a storage architecture 100% flash, and indeed, we have done that for some customers. However, for the majority of customers, they're going to need to find a much more efficient architecture. That efficient architecture, the first starting point is, if I'm buying storage and capacity, let's make sure I can get as much performance out of the HDD systems that I'm buying. That makes perfect sense, right? You're going to buy that for capacity anyway. Let's get as much performance out of that as possible. And then why don't we supplement that with various amounts of flash, depending on what my workload is, because in some cases, adding flash there may not actually give you any benefit at all. So it's really important to understand the overall supercomputer architecture, the budget constraints, how much capacity, and then you can look at the workload and say, right, will flash give me a benefit or not?
Well, great. Being here at the Supercomputing Conference, what do you got looking forward as you talk to customers this week?
Very interestingly, Rich, we're starting to have early conversations with customers as they look towards the end of this decade and start really thinking about exascale. This is an area that actually Europe is at the forefront of, and actually Seagate's heavily involved in that. We're actually awarded the exascale I/O contract as part of the Horizon 2020 program. So that project is specifically called SAGE, where Seagate has brought together a broad ecosystem of partners ranging from end users, application vendors, ISVs, CPU vendors, interconnect vendors, and server vendors. And what we're all doing together is really looking at the challenge of exascale within the context of that data-centric model. And some of the aspects that we look at there is when you think about exascale, it's not just in terms of scale, in terms of horizontal scale and hundreds of thousands, maybe millions of compute cores. It's also about the vertical scale from a storage perspective. We've got to be careful that we don't add too many storage layers. As you know, when you talk with customers, we already struggle with just backing up the tape. When you start thinking about adding more and more layers in the memory hierarchy, high performance disk, and tape. So we're really thinking about, and part of our key premise of SAGE is what we call rampant layering violation. How do we reduce, not increase, but reduce the number of layers? And instead of having that storage architecture made up of discrete pieces of software stacks, how do we bring that together into more of a homogeneous environment? Because as you know, data movement is both expensive and extremely challenging. Another aspect of that is, of data movement is, how do you not just take the data and ship it to the supercomputer? How do you take advantage of more and more of the processing that now exists within these storage systems and actually do some of the processing closer to the data? So a lot of these conversations we're having with our customers as we really think towards that path towards exascale.